let's go over the exam. All right, so first question is, most of you got. There are other control variables in here. So the absolute correct answer to part A would be, after adjusting for differences in mother's education, family structure, and birth rate, the difference in mean education, or I'm sorry, mean age 8 math scores, that's a dependent variable, between children, I'm sorry, so you're not, this is mother's education, so after adjusting for differences in family structure and birth weight, age 8 math scores differ in terms of their means between children whose mothers have 16 or more years of education, as opposed to just 12 years of education, by 6.18 points. Okay, so if people didn't put the after controlling for everything else, and it's 4 points. So these are these coefficients represent group adjusted means relative to the mid category. Right? You can't say anything about an additional year of education because all you're doing is going from one group to another. You're just comparing these group differences. So describe the approximate shape. So all you know, I tried to say, think about this one a bit. Simple graph might help. You just have these categories, right? You've got less than 12, 12, 13 to 15, and 16 plus. Right? And these are education categories, right? And they're not on any sort of linear scale, right? Being in 12 isn't twice what being in less than 12 is, and being 13 to 15, isn't 50% higher than 12. So the underlying linear scale is just years that might have 12, 16, and so forth. And all you know from the regression results is that the people who are down here at the less than 12 category, you know that the 12s are right at the 0 point in terms of relative test scores, right? Because they're the omitted category. All you know is that the less than 12 years, minus 5, plus 5, plus 10, on this relative scale, are 3.67 years less. So what you're really doing is just fitting a line to whatever scatter points there is. You don't really know whether the points are individual points. If you somehow have measured education continuously, you don't really know whether they're going up. They could be going down, right? All you know is that when you fit this dummy variable, on average, the less than 12s are 3.67 points less than the 12s. And similarly for the 13 to 15s, they're 3.08 more. You don't really know within that group whether they're just flat, all at the same value, upward sloping. And for the 16 plus, you don't really know where 16 plus is. Presumably most of them are at 16, but there's going to be a 6.18 deviation up here, a 3.08 positive deviation here, and a minus 3.67 deviation here. So if you knew what the mean was for, let's say, the 16 or more, then you know that this 6.18 applied to mean education for the 16 plus groups. Right? If you knew what the mean was between 13 and 15, let's say it's in the middle. Again, we don't know this from the question, but if you could calculate a mean for 13 to 15s, that's the mean for 12s. You know that, it's exactly 12. And who knows what the mean amount of education is for people with less than 12. Let's say it's here, right? If you knew what the mean levels were, then these would be the points that the regression would be implicitly fitting to. So you could look at that pattern of means and decide whether it seemed to be linearly increasing or log increasing, right? But just knowing the information that is presented in the problem, you don't, all you know is everyone below 12 collectively has this mean. Everyone 13 and 15 collectively has that mean. Everyone up here has collectively has that mean. So you really have to be careful when you're dealing with categorical variables here to get a sense of where the distribution is. If you know, the very first day of class, we had this example where we had children's schooling, and income, right? And there was less than 15, 15 to 25, 25 to 35, 35 to 50, and then 50 plus $1,000. That was a scale. And you know, you had a pretty, if you look at the dummy variable categories, it's a fairly steep increase. It starts to fade here. So where do you put the 50 plus point? You know, if it's higher, and if you just put it, you know, carelessly up here, the whole thing looks pretty linear. But it turns out that the mean of everyone above 50,000 was way out here at 80,000 or so. So that point isn't up there, it's really over here, which gives you a very different idea of what the functional form looks like. So make sure you distinguish between a categorical scale and a linear scale. And you know, some people, when they actually do empirical work, if this is the only way that the data are given to them, not as years of education, but as categories, you could do worse than, you know, this is 12 if you convert it to years. Education is pretty uniform between 12 and 16, so a midpoint of 14 is probably a good representation for that. You can probably determine that the mean of people with less than 12 is 10 to 11 years. And up here, most of the people are at 16, so 17 isn't an unreasonable guess at what the average education is. And sometimes people just convert this kind of scale into a linear version of the variable that it's representing, and just stick that in the regression, because it's going to be close enough. But you have to make sure you go through this logic of what those categories really contain. All right, so yeah.
Okay, I understand this, what you did here with this, but I thought that you were supposed to use a standardized coefficient coefficient so that you could say the constant for the people at 12 years is 0. And if you use the standardized coefficients, you get the same general.
But that's, so I plotted this knowing that 12 was in this category.
Right. But if you're at 12 years, then isn't your value some unknown constant that isn't given by the table, since these are not standardized?
The constant for this regression, if the other variables are set at their means, would be the mean test score for kids whose mothers had 12 years of education, right? That would be, the admitted category becomes the constant, unless that gets shifted around by the other variables. So we could have presented this, if we knew what that number was, this might have been 102.
Right, it would still give the same.
This would be
shape.
3.67 points less than whatever it is, right? So you
Right,
can
right.
change the scale so that it represented actual number of points on the test. Or you could, standardize this whole thing so that the whole sample mean is 0. And then this would probably be a little bit less than that mean. This would be like 3.67 points less than that. So there are various ways of presenting it. But that's not going to change what
The shape of it.
the shape of it, right?
And the shape would be, have we decided the answer is linear?
If it's reasonable that this is the mean value of maternal education for people with less than 12, this is a reasonable value for 13 to 15, and this is a reasonable value. So you have to, the problem doesn't tell you that these are the right numbers. You've got to bring additional information. Sometimes in the data set, it will be data specific to years of mother's education, and you might just choose to do the dummy variables anyway. So you could just look at mean education 13, 15, mean education 16 plus. So even if you have a continuous measure of years of education, you still might want to do this if you think there's a nonlinear function. This would reveal what the nonlinearity of that. Okay, any other question? Okay, how would you go about testing whether the coefficients on 13 to 15 years and 16 plus are significantly different? Easiest way is just to rerun the regression, leaving out not 12 years, but either 13 to 15 or 16 plus. Right, that's the easiest. Some of you use this formula that for the standard error of the difference of the square root of the squared standard errors. And that works for testing coefficient differences in independent samples. If you've got two categories that are part of the same sample, there's covariance between the coefficients. I didn't want to get too complicated, but it's really these standard errors squared, it's either minus or plus 2 times the covariance in the coefficients. So if samples are independent from one another, there's no covariance. But if you've got two categories that are part of the same variable, there's going to be a negative covariance between them. So that isn't quite right. I'm not sure I don't think I took off very much at all for people who gave this. But for future reference, it works very well for independent samples, and it may not work for two means that are dependent. And if you've got two categories of the same variable, those are going to be dependent on one another. Other people said just do a post-test to try to see if the coefficient on these two categories were significantly different from one another. Right? Post-test on this regression to see if 3.06 was significantly different from 6.18. That's another way to do it. question about number 1? All right, number 5, otherwise known as number 2. Interpret the coefficient on the minus 12.45. So a lot of people said increase in task value associated with 1 year of education. That's not right for 2 reasons. First of all, there are interactions here. So there's a whether Hispanic times age in addition to age, so that if there's a complete set of Hispanic interactions, then the non-interactive term is just telling you coefficients for the non-Hispanics, right? But further complicating this is that it's quadratic, right? So if you've got a quadratic in age, the estimated association between age and task value is continuously changing as you get older and older, right? The quadratic ends up looking something like this. And so to say that, you know, every year is associated with a 12.45 point decrease in task value, that can't be right, because the slope is changing all the way through the age range, right? So the 12.45, it turns out, is the slope of the parabola where age equals 0. Right? Remember we talked about if we have task value age plus, or task value is a function of a constant plus age squared. Right? The slope, which is the derivative of task value with respect to age, is just b1 plus 2b2 age. Right? That's the formula for the slope, which is what we want here. That's the interpretation. And b1, the coefficient on age, is just the slope when age is 0. Right? Plug in age equals 0, and the slope is b1. So that's the interpretation for b1. So it's the interpretation is an additional year of age for non-Hispanics is associated with a drop of 12.45 units at age 0. You know, which turns out to be a ridiculous value given the sample, but that's what the minus 12.45 means. Elizabeth.
So, I didn't do this out on the calculator, but it looked like these interactions weren't significant.
But regardless, if you want to interpret minus 12.45,
Right, I get the second half first, but it didn't look like there was a difference between Hispanics and non-Hispanics.
okay, so even if the coefficients aren't significant, your best guess of what those coefficients are isn't 0. Your best guess of what those coefficients are is the estimated set of coefficients.
Right, but on the homework, didn't we have sort of a similar question where we said that the form wasn't really different between Hispanics and Vietnamese because those interactions were not significant?
Right, right. But the question asked you to interpret the minus 12.45.
Right, so, okay, then I think I'm confused, because you have age in years, and then you have whether Hispanic times age.
Right.
Right, but wouldn't, okay, I'm confused, because it doesn't seem like there is any, because that coefficient's not significant, it doesn't seem like there's any difference in the shape between Hispanics and non-Hispanics.
Yeah, I mean, it's really close, if the standard error, the 6.40 standard error, right? But regardless of whether it was close or not, Your best guess of what the slope of the relationship is for non-Hispanics at age 0 is minus 12.45, and for Hispanics, it's 11.75 points more than that, right? It's close to 0. That's your best guess. Those two things may not be significantly different from one another. And if you left out the interactions, you'd probably get some sort of coefficient that was halfway in between. But that's beside the point of what the question is asking for, which is, what does that number 12.45 mean? That's not asking about significance, it's asking about coefficient interpretation.
Right, I guess I was just confused about the non-Hispanics versus everyone, that's all.
But you see that just, that algebra tells you, if you've got this equation, and a non-Hispanic individual is 0 on the whether Hispanic variables, that the 12.45, minus 12.45 is the estimate, best estimate, may not be significant or not, from the equation of what the slope of fast value with respect to age is at age 0 for non-Hispanics.
Yeah, okay,
I know, but so,
I think
so I'm saying, so there are two different things. One is, what's your best guess based on the regression results of what these coefficients are? What the parameter estimates of your model of interest are? And forget about standard errors, these coefficients taken together are your best estimate of what these coefficients are. They may not be significant or not, but suppose minus 12.45 was, it's kind of borderline significant, but suppose the standard error were 10 instead of 6, right? It'd be very insignificant. So is your best guess of the slope 0? Or is your best guess of the slope for non-Hispanics at age 0 minus 12.45?
I see what you're saying.
Okay, it's an important distinction. We talked about it in the context of mediation as well. Just because a total effect may fall below significance when you put in mediators and end up estimating a direct effect. That doesn't mean that your best estimate of mediation is 100%. Your best estimate of the degree of mediation is just whatever your best estimate of mediation divided by the total effect is. Same kind of thing. The difference between coefficient estimates and statistical significance. Okay, shape of the task, age task value relationship. Most of you, I think everyone saw it was quadratic. Almost everyone said what kind of parabola it was, that it was a U-shape and not inverted U-shape. And then I think almost everyone got the minimum value of 12.7, I think is what it was. Okay, any other question about that? All right, so now we've got this mediational question with two mediators. That was the wrinkle that I was hoping you would successfully navigate. So we've got reading achievement, family income, stress, maternal stress, and childcare quality. And we have background control variables. arrows everywhere, right? Including from background controls. Total effects,
For the background controls, are those arrows inclined to stress and childcare quality reading achievement?
these,
Or where do they point to? Or is it just there?
I'll, make it explicit. You know,
Is it not
before-
related to income at all?
What's that?
Is it not related to income at all, by any chance, or?
Yeah, the convention is usually to consider these things correlated and not causal. That,
Okay.
George talked about that, right? There's been a curved arrow and a straight arrow. But, you know, you shouldn't just throw this stuff in. You should ask, what equation best provides me with the coefficients that I want in an unbiased way? All right? So, we might be focused on reading achievement as a function, the total effect of income plus controls. Right, that's family income, controls. Easiest way to do this for the total effect is just leave out the mediators altogether and run this regression. Reading is a function of family income and controls. You've got to ask yourself, is that the best I can do for reducing bias to what I really want, which is an estimate of family income effects on reading, and are these controls sufficient to do that? So you want all the controls possible to get you the best unbiased estimate of the effective family income on reading. That governs your controls. But the same thing can be said for stress. You know, for this part of the indirect effect through stress, stress is a dependent variable, family income is an independent variable, and background controls are there too. How do we estimate the best unbiased effect of family income on stress? Well, you need to put in a lot of background controls, so you want to attribute to family income what will really be attributed to other things. So the background controls, some sort of background controls should be part of that equation. They should also be part of the childcare quality equation. You want an effective family income on childcare quality that's as unbiased as possible. So you want to put in the background variables important for that. Right? So each of these key paths, you know, direct and indirect effects, should come from your best shot at causal estimation equation. So total effects, you've got to have background controls in there, and it's this B1 that's the total effect that you then decompose into a direct effect, indirect effect.
Right, for this equation, instead of putting B2 controls, I just put plus E, because sometimes you mention like, well, if you just throw an error, because that's for something that we didn't take account of, so.
Right, so
that'd be,
the convention is that E is everything
Right.
else that isn't measured
right,
and can't be controlled explicitly.
I see, so you're talking about things that can be controlled explicitly.
I tried to spell those out. So, you know, I apologize for not being clear on what, you know, for the Wooldridge, econometricians worship the error term.
Right.
You know, it's really all about the error term. That's how they think about things. For us, I think it's easier to think about what the error term represents, which are these important unmeasured variables. But if you've got measured controls to put in to help reduce the bias, you're always better off. And so I've tried to set up the problem so that it was clear that there were such controls that you could control for. And, you know, the total effect isn't just the simple correlation. It's really the adjusted correlation after you take into account controls. And I think, you know, almost everyone, apart from thinking about including controls, understood that a direct effect came from an equation of reading as a function of everything with arrows running to reading. Stress, childcare quality, income, plus these other controls. And then you needed these additional regressions to nail down the indirect effects. Stress equals E plus F1 income plus F2 controls, and then childcare quality G plus H1 income plus H2 controls. So this is D1, this is D2, this is D3, this is F1, this is H1, and we could have put in the control coefficients too, but they're not important for the calculation of the indirect effect, which is the product of these paths relative to the total effect that you estimated in the first equation. A lot of people successfully understood that. Any other question about that? If people want to, I'd be glad to meet one-on-one with people if they have lingering questions. How would you express the regression estimate from A of the standardized coefficient? I think everyone understood that you multiply by the ratio of the standard deviation of the x variable, the standard deviation of the y variable, and then the fraction of total effect that's accounted for by maternal stress. To answer that question, you do need a control for childcare quality at the same time. It's part of the system. I think most of you got that, but some of you didn't. So even if the focus is on maternal stress, you can't get a good estimate of the effect of stress on reading achievement without controlling at the same time for childcare quality. It's a standard sort of limited variable argument. Right? Both of those were mediators here. And then number 4, most of you got that. Dependent variable was high school completion. It was dichotomous. Independent variable, motivation. So the 0.405 is from a log of the odds of high school completion as a function of motivation. So 1 unit increase in motivation is associated with a 0.405 unit increase in the log odds of completing high school. Marginal effects converts that into a probability of completing high school. So evaluated the mean value of all the independent variables. So the interpretation of 0.089 is that an additional unit of motivation is associated with 8.9 percentage point increase in the probability of high school completion. Okay, any questions? Should we talk 1 minute about the paper? Has Emily done her workshop already on that
Yeah.
UCLSK? Okay. So the paper is, an investigation of some hypothesis using longitudinal data that can either be the motivation data set, it can be the ECLSK data set, it can be any other data set that you might be running into in your research. It doesn't have to have very much of literature review, but it should set up in the introduction what the hypothesis you want to test is. And it should describe the variables that you're using in the analysis. It should describe the analytic strategy that you're adopting to come up with the best unbiased estimate of your hypothesis, unbiased test of the hypothesis. Present the results in a very clear way, which is to say, not cutting and pasting from data output, but actually transplanting the tables from the output into a clear table. When you label your independent variables, they don't have to be confined to 8 characters. They can have wonderfully long descriptive labels that tell the reader exactly what the variables mean. And then there should be a very short conclusion. So I'm eager to provide advice about what these papers might look like. If you do use your own data, make sure you go through some of the descriptive steps that Taya has walked you through. We haven't really talked about how outliers can influence your estimates, but it's, if you've got even one erroneously coded observation among 1,000, if it's your dependent variable and if it's a sufficiently extreme observation, it can throw off your estimate by a lot. So you want to describe your data. You want to take a look at it. You've got graphing tools that you can use, lab description. Procedures are available in Stata, so make sure you really know your data before you start in on the actual analysis. That's always a good bit of advice. And then go to it.
About how long is a paper supposed to read? As long as
I don't know, long enough to reach the ground. It doesn't have to be. Articles are usually 25 double-spaced pages, right? But they usually have very big literature review sections. Papers are often half that size, but and they're simpler in a number of other dimensions. But you really do want to clearly lay out what your hypothesis is, clearly explain your data. When you're doing an article and in this paper, provide enough detail so that if I were to get a hold of your data, I could understand and reproduce exactly what you did with the data. How you constructed the variables, how you selected your sample.
Do you want us to submit our code?
Please no. Did you see the idiot Florida congressman who, used to be the decennial census, every 6th or 7th household would get what they call the long form, which had income and all sorts of stuff that's used all the time for federal programs as well as by businesses to identify where, you know, high income, low income neighborhoods are, but all sorts of demographic information, house value, things like that. So, the census, maybe 10 years ago has switched to just a decennial census that is just the facts, race, the population counts, you know, the kind of things that you need to apportion congressional districts. And, you know, you don't need race for that, but there's some other vital need to have all that recorded for everyone in the population. And then there's this rolling census of a sample, random sample of households that is providing the long form information. So between the censuses on a continuous basis, there's this called American Community Survey that's providing all the other stuff. And the House of Representatives actually voted to eliminate the American Community Survey. And the first term Florida congressman was saying, it's not representative, it's random. Didn't realize that a random sample is a representative sample. But anyway, this is what we have to deal with. All right, so I digress. The description of how you do the sample should be clear enough so that I could do it if I were so inclined. That's a general thing for writing up papers. It doesn't have to be long. You can be very concise when you describe how you code things up. But, you know, it has to be clear. Usually there's, the first table is just a descriptive table that shows means and standard deviations or proportions if it's 0 and 1 variables for all the variables in your analysis, dependent and independent. You know, followed by the regression tables. Graphs are welcomed if they make sense. Not if they don't. So, you know, try to come up with a directed hypothesis. Don't just say task value is associated with mass scores. Take a stand. You know, predict that males will have a stronger association for the task value test score relationship than females will. That's a hypothesis you can actually test. So it doesn't have to be right. You can actually, if your hypothesis is not supported, that's as valuable as if it is, even though you'll never get it published. So, any questions? Yeah.
Should it be an education-related topic, or?
Doesn't have to be.
Okay.
Doesn't have to be. Just has to be longitudinal and hypothesis driven.
When is this due?
I said
June 11th
June 11th.
on the syllabus.
Okay, whenever I said
I email you?
the paper, sure. Either way, it's fine.
The other option being putting it in your box, cause I don't think we see that day.
Yeah, also do a Dropbox on AAA, whatever.
Yeah, I prefer direct email or just putting it in my box upstairs. Either way is fine.
What time did you do? Just, is it like 9 AM?
Not 9 AM.
Before you leave?
I would, so
Try and speed up.
8:59 PM. How about that?
59.
No one should work until midnight ever. So-
Really? Really?
Make that
Right.
up.
You should get up early in the morning. So 8:59 PM. It's nice being up here.
Hawaiian time.
You know. Okay. Any other questions? so I hope what we're gonna do today will be helpful in thinking about the papers. One thing that is problematic about a lot of lunchroom research is that people think first of the empirical models that they want to use rather than the theoretical models that drive the research questions, right? So let's think first about conceptual models of change. Now, things like latent growth models, residualized change models, those are empirical models of change. They're not conceptual models of change. So it's vital to think conceptually before you start diving into any sort of empirical analysis. So what are possibilities? One is instantaneous change. This means if I have a relationship between some independent variable x and some dependent variable y, that a change in x would be expected to lead very, very quickly to a change in y. Right? So suppose we had child behavior problems. As a function of family income. You could imagine that if family income takes a turn for the worse from unemployment or something like that, that there might be pretty quick changes in the development of child behavior problems if there's a lot of stress in the family and so forth. So if we think about adding time subscripts, an instantaneous change model would be child behavior problems at time t is a function of family income right around time t. And then we want to have these other determinants, some of which we can measure and some of which we can't. So zt is other determinants that vary with time. And then we'll have zp for permanent, other determinants of behavior problems that are time invariant. Permanent or persistent. Okay, that's probably not going to characterize a lot of things, but it may characterize certain things. Another kind of model, very different, is what we could call accumulation of inputs. This is probably more relevant for cognitive kind of outcomes, achievement outcomes. They're gradual processes. They build up over time. So we might have child achievement at time t is a function of now it's not just family income at time t, but it's a whole history of family income, all the way back to birth potentially. Right? You can think of something that develops very slowly as a function of a whole past history of influence. So we could think of it as the sum of family income from time 0 to time t. Alright, so this is child achievement at age 5. This would be adding up family income in the birth year, age 1, age 2, age 3, age 4, age 5. It's that total amount of income that's going to be spent in ways that might benefit the child or not. Great. Sure. Yeah.
For these equations that we write in yours, we don't have interactions, and I feel like sometimes interaction, when you write interaction terms, it's almost like an art in a sense, like, I don't, sometimes you have it, sometimes you don't, and how do you know? Is there some sort of rule that you go by that you should put interactions in, and?
I pray every night that I don't encounter interactions the next day, because they're very annoying. They're usually a function of an additional set of considerations that lead you to want to go beyond a mean effect to think about differential effects, right? This is kind of a main effect of family income. You can imagine family income might have a differential effect on boys versus girls, so a gender interaction, right? If that's the case, you'd want to put in, whether male and then whether male times family income. But that's taking this main effect and then parsing it up into some interaction. So the main effect is really an average of two different effects that are hypothesized between, say, males and females, two different groups. Interactions are always possible in almost anything that I've been talking about. To keep things simple, I've generally avoided them, except when they became an explicit part of what we had to learn. But a useful maintained hypothesis is that there are no interactions, and then get that right, and then start thinking about the complications for interactions.
Like, for example, on this quiz that we just took,
Right.
Hispanic age, why would you need to do the interaction between Hispanic age, and what is that, what significance would that have if you took it out or left it?
You mean the whole set of Hispanic interactions?
Yeah, right, you have Hispanic and age as an interaction, do we need to put that, because you have age and Hispanic already as two separate variables.
Right.
So do we need to have?
Well,
that? And
if there's some reason to think that the relationship between age and the dependent variable differ between Hispanics and non-Hispanics, then just having two separate additive effects of age and Hispanic, that's not going to capture that at all, right? So we could put in, before whether male, we have the gender of the kid,
right.
That's going to have no effect on this coefficient, because gender is pretty much independent of family conditions, right? But if you really think that the effect of family income on behavior problems differs, then this is totally inadequate to tell you that, right? You're going to have B5 times male times income. So only with laying out the interaction and including it are you going to allow for the fact that family income effects on achievement or behavior problems in this case might differ between the two groups. So if it's part of your research problem, then you need it. If it's not, there still might be interactions that are working around your data. But people usually confine papers to either just main effects and getting those right, or the paper is exclusively about interactions, gender differences in X. And then, of course, you need the interactions all the time. So let's ignore those for the time being, if that's all right. Because it's gonna be tough enough just with the main effects before we get into the interactions. All right, so accumulation of inputs. This probably works for most learning, right? If you think about a child's achievement in 5th grade and think about the school resources that went into 5th grade achievement, it's a function of what they come to school with, but also the whole pattern of teacher quality that they experience, peer influences that they experienced. It's an accumulation probably of all the inputs up to 5th grade that are determining a child's achievement in 5th grade. It's not the case that if you've got a good teacher for a month, all of a sudden achievement's going to be much bigger or much lower. And regrettably, we've got the same potentially omitted variables to worry about. That can also be either time varying or persistent. You could also think of a lag change kind of model. Maybe child behavior in time t isn't reacting to immediate things, but it reacts to things that happened a year ago. So family income t-1 plus the ZT and the ZP. Okay, so these are just generic formulations. All it takes, if you want to estimate this, provided that you've got the Z variables measured, is cross-sectional data, right? You can go out and measure child behavior problems and family income at the same time. As I say, provided that you're controlling for everything that you need control for, the cross-sectional data will give you a good estimate of E1. Not so with accumulation of inputs, right? Somehow you have to gather information not just on family income at time t, but the whole history of family income. Right? So either you have to rely on people's memories to recall past quantities of income, which we know is going to be unreliable, or you need some sort of a longitudinal study where you're following kids every year and their families. Note here that even if you've got child achievement measured all the way through life, as well as income, this version of the equation just says you wouldn't use any of that earlier child achievement information. Just take the most recent one, but relate it to the whole history of family income, because that's what corresponds to the conceptual model of accumulation of inputs. And for lag change, you're going to need at least a couple of waves of data, t and t-1, right? You pick the child behavior report in period t and the family income report in t-1, and you estimate that. Okay, everyone see this? So, after we have this understanding of the kind of conceptual process, now we can think about variations for estimating these models that might, all of them take advantage of longitudinal data in a better way, better in the sense that they're arguably delivering better, less biased estimates of coefficients here.
Is there like a general definition of longitudinal data? Is it over a year, 3 years, 5 years? Is it?
It's really just more than once, right? The distinction is usually between cross-sectional data, which is gathered at a single point in time, versus longitudinal data, which has gathered data on the same units, the same people, the same families at multiple points in time.
So let's say if I was interested in somebody's, I don't know, whatever their eating habits for the day, or their calorie consumption, if I measured it over time, it would like over a day, but every 30 minutes or something like that, would that still be considered? Or does it have to be like a long period of time?
Yeah, that's a good question. If technically longitudinal data, as long as you are measuring more than once, it's longitudinal, right? You may end up averaging over all the waves. You know, it might be every day for a week, and you might be using weekly expenditures on food. Even though you're just using a single measure of weekly expenditures on food, it's still longitudinal analysis in a manner of speaking because you gathered the information more than once. Usually, longitudinal models are models where the conceptual variables themselves come with different time subscripts, right? So, you know, if it's food expenditures in that week as a function of income that week, even though you went out and interviewed every day, that would be considered a cross-sectional kind of model because it's weekly income as a function, or weekly expenditures as a function of weekly income. But, you know, this is an inherently longitudinal model because family income is measured not just once, but over 5 years leading up to age 5. This is an inherently longitudinal model as you're relating child behavior at time t to family income at time t minus 1. You have to have multiple measurements to do that. Okay. So we can take a break for a couple of years. How many votes for a couple of years? For a few minutes. It'd be nice if the classroom were cooler again, huh? What we're going to do now is suppose we do have longitudinal data. Is there a way of using it to get less biased estimates of these models? And that'll take us into the NICHD childcare quality argument. Okay, 2 minutes.
Well, you know, you've been doing that with everything else, haven't we? All of it. I don't think mine sent up to get so.
There are, okay, I guess technically.
You go check out the camera. You think they have a clicker thing that I can, I'm gonna go explore there.
Oh, that's where I went to college. And the chairs are set up for graduate comments.
PowerPoint.
And that's just the like
They have it.
lecture hall for one of the.
You just go in and you check, when you check out your camera. Yeah. Sure. They probably have it. The process is you just go in and
So I park here.
sign it up, right?
Yeah.
Tomorrow.
This is,
Yeah, they're cool.
yeah, is that the 7 or
And then walk around.
207
It's
394
much more fun to
or
walk
not?
around while
That's okay. No, I just,
apparently more.
8816. Okay. So I'll give her a call when I'm somewhere around here. Alright. You're welcome. Then I went to brunch on Sunday here with your group. Yeah, just went back early. Go.
I don't know.
Yeah, or that's who you,
Um,
maybe it's not your group, but your standard brunch.
Because it's
Yeah, and I
kind of-
got two mini bonuses, but that's okay, so we had to
Well,
totally, we had to spend too much time at brunch, cause I was like, too drunk to drive home, too drunk to drive home, let's
I
go.
don't remember.
It was nice. What did you do?
No schoolwork, no yoga, nothing, yeah, oh, well, that's still a plan.
According to this house,
We have an entire
I was
garage.
Flying, yeah.
It's
Subway for where you're.
We have an entire garage full, an entire shed, I've been there 3 years, but we have David's mom's stuff. 77 years of accumulation, 80 or 78 years, basically.
oh, do you know why?
Right.
Are you gonna do a garage sale, or are you just?
We're gonna just move and do it there, we can leave some of the stuff that we have to sell there, and then we've done a garage sale before. Yeah, so most of the stuff we can't get rid of, 'cause it's
You probably just left off some important detail. Semi.
so, and she just moved too, we moved her 3 weeks ago.
It looks like
so-
whatever he deemed off one point,
This is my
it
whole
was
life,
like
is
you're
just
missing like a control
moving people
or
and
missing
us.
something.
I mean, yeah, I know.
So anyways,
Here,
that was
this is
my
really tricky.
That one makes
It's
sense.
like, yeah, we should improve the controls.
Always,
I get it.
yeah, always consider it.
Okay.
But
Because I can't
We do that.
remember.
Yeah, I know, that's what I
Right.
started to
And
say.
not two is you can send like.
You know,
Or-
you say that, I can't respond to that.
I know.
In any way, right?
Like,
Like, there's no way I-
yes. Yes.
Like,
Or I guess.
okay.
I just emailed them
Take a
with
look.
her slides, but she has a shoe share out with us.
Should be good.
I know it was on there too, so she's trying to find it.
No,
She'll get it to us.
Yeah.
And then I thought it was crazy, cause it's like, where it was, so I'm not crazy.
I went to bed on
I like doing both.
like Friday night or something at like 9 o'clock. And I still could barely get up on Saturday morning. And last night I did that at like 1:30.
Somebody,
I'm
really
sure
much
it's
worse.
like 4 a.m.
I'm not sure what, I don't know how. Oh, you did it by registration?
What a homing meeting.
It's the same thing.
Where'd you go?
I didn't want it.
Well, because I went with my friend Zyra and her sister and 4 of their cousins, and 2 of them were like, one just turned college and the other one like is also, they were like the
You
youngest
standardize
there.
why, you standardize, you put it in this for this, this for that.
And so
That's
we
what you got.
I think it's just not.
we were just like,
Uh,
she was like, because they were just like
So you
advanced.
didn't lose that.
The mathematics.
Well, we left them with the other 2 cousins and they
You're
also
standardizing the scores
and we were like really worried, because she didn't sell
But why you do that?
because she got mad at
forget.
everything and so well.
Also, that's where to go.
And we didn't know if she had money.
It's easy to memorize mathematical equations.
And she just made me fortune.
How long were you guys there?
We were there Friday, Saturday,
Where did you stay?
we were there, yeah.
I feel like we've got to make it a lot.
I went in October.
That's a lot of time.
But, you know, this is,
Clearly I'm just rejecting me.
when I was reading questions, this looks like to the really simple exam.
We found the girl.
That's good, I'm glad I
Yes,
put
but
on
you
there.
want-
She had
I
like,
know, that's the,
she like
that's
sent
this
a
one,
text
so
from her
that's
straight to her cell phone and was like, I'm
Are Are these the papers for our class here?
I think so.
Okay.
I just emailed mine.
Okay.
I'll send you a copy.
If everyone's printing it out, I'll just have everybody emailing it. Email is the same thing.
I just think who cares?
Me out there.
I just thought it's, you know.
He's just gonna print it out anyway. That's good.
We'll just start shooting. They turn in their.
Most people do. I like having it. And I like receiving a digital copy because I don't print it out.
Does he give it back to you? By electronic? I always print it out.
He usually prints it out, yeah. I also
And
like,
that's every paper. It's either you or him.
I also like looking at the timestamps on the thing, the file, to see when it was finished and all that.
He doesn't doubt you or anything.
Well, he doesn't, but I like that. I'm getting paper. TA.
Oh, yeah. Especially if you have large classes.
I've used it to help people's cases, like sometimes I forget to turn it in or something. I just look at the timestamp and if they finished it like the night before, then I'm like, yeah, no, I know you did it correctly and on time. You turned it in late. Just don't modify it. Although it says when it was created. If it's modified, then that's the last time you touched it, you probably shouldn't.
Yeah, because if you modify it, you have to put it there again.
No, I didn't like that either.
But it tells you every time it's been modified if you look into the, well, at least we're talking about this. Like,
Do you know what you're gonna write for this paper?
oh, I'm gonna ask them if I can use my the stuff I have to do for my paper anyway.
That's what I'm gonna do too.
Yeah.
Because it's due at the end of the quarter for me, so I might.
Two birds, one stone.
I just don't know because like my main thing is about stereotypes. And even though I have longitudinal data, like it doesn't ask about stereotypes both years.
You don't need it both years.
That's fine, right? I mean for this
What,
activity.
okay, well, first off, what year does it ask for?
What year?
What
It's
year
still
is your data? Because you
2002, 2004, 2006, but I'm only focusing on 2002 and 2004 for the parts that I'm interested in for this thing that I'm doing right now.
If you can have some parts of your equation be from one time period, and then the rest of it can be over time.
Well, I'm mostly looking like at 10 or 12 variables, and like the ones I'm interested in, like the main ones, are either from one year or the other.
Hopefully they're in it. It's usually better for a solid that comes before something, and then you look at the change.
Yeah.
Yeah, like a before and after kind of situation. But,
Well, I'm just wondering, do we have to like, so, you know how we did like our homework where we had to do like wave 6 minus wave 0? Like, do we have to do something like that, or using the same variable as the average? Is that important for him? Because it won't work out. I mean, I could look at other variables else. I don't want to. I want to do whatever.
I feel like you should do leeway there, just because it's so longitudinal as long as you're using you have like a change in time and stuff. But
I'll double check.
it's easier if it was. Well, I keep pointing out the end result of the achievement is fine, but then the other part is longitudinal. That's a little bit better than if it's the other way around. But I don't know. We'll figure it out.
I didn't know we didn't have a final for this class. I didn't know we didn't have a final for this class.
I know. I'm happy.
I just found it out.
You just found that out?
Yeah, right now I was looking at, I'm like, when is our final?
No, the midterm was the only paper, the in class.
This quarter's getting better.
Yeah.
Because we don't have a final for SLG either.
Most of my classes are intense right now, and then they kind of mellow out.
Well, usually it's not like that. It's like it starts getting into this midterm and then it gets really hard.
I have eighth week and ninth week are hardest for me. I have a lecture I have to do tomorrow. I have an hour-long lecture to present. That's worse than a presentation. Huh?
Mine is worse. Well, Estella's class is pretty much like that. It's a whole bunch.
Well, I suppose you're right.
That one was like the time I had to get people talk to you.
This one I basically have to make up what the lesson plan is. for that day. So that's kind of pressure, especially since I wasn't really given any like specifics.
Shocker.
There's no specific topic to cover. There's just a general topic that I can cover. So I was like, what am I talking about? Where'd my
You have a
origin?
plan already, right?
Yeah, of course I have a plan.
Like, it's due tomorrow. It's like, sounded like you did.
No, I kind of had to turn it in a week early just so that the lecture is not.
Okay, let's start up again. So now that we've got clarity in the conceptual models, let's think about what change version of these models might help us do. So we said in this first instantaneous change equation, you just needed cross-sectional data, right? Go out and measure child behavior problems at time t, family income at time t. You could run that regression. Let's call this 1, 2, and 3. For model 1, suppose you had observations at age equals 3 and age equals 5. Right? You could estimate this with age 5 data and get a coefficient of income. You could estimate this with age 3 income, totally separate regression, and get some estimate. If it's the case that behavior problems at age 5 are a function of income at age 5 plus CT plus CP, and behavior problems at age 3 have an identical functional form. Income at age 3 then you could estimate, if you have this age 3 and age 5 data, change in behavior problems age 5 minus age 3, right? Subtract the second equation from the first. Then you're going to get a change in behavior problems age 3 to age 5 is a function of beta 1 times change in income age 5 minus income at age 3. Right? We're just subtracting B1 income 3 from B1 income 5. And it's a common B1 coefficient, so it's just that coefficient times the change in income between 3 and 5, plus B2 times change in time varying variable z, but the time invariant component zp gets different side of the equation. We're talking about this in the context of sibling models, right? Sibling fixed effects models. If you estimate this change equation, change in behavior problems, this minus this, is a function of change in income, this minus this, plus change in this we can put as age 5, this we can put as age 3. ZP is the same, doesn't change because it's persistent, right? then we just estimate change as a function of change and change. And there's no longer any biasing effect of time persistent determinants, whether we can measure them or not, of behavior problems. Which is a huge advantage. So two things to note here. Let's call this equation A, equation B, and equation C. First thing to note is that equation C is not plagued by omitted variable bias from ZP. So any sort of characteristics of parents, characteristics of neighborhoods, characteristics of the home environment that are constant across at least this portion of a child's childhood, ages 3 to 5. Any potential influence in behavior problems are going to potentially bias A and B, but they're not going to bias C, which is the change version, because they're getting different stuff. So that's a huge advantage to a change equation. And the second thing to notice is that B1 in equation C is identical to B1 in equations A and B. Right, so what does that mean? Back at the conceptual stage, we were thinking of instantaneous change could be characterized in this kind of way. So we really want a causal impact estimate of the effect of family income on behavior problems. We might be able to get that if we could control for everything else that was relevant as a determinant of child behavior problems. That's unlikely. So at least with respect to the persistent characteristic Z, we can get rid of them if we do a change equation. But the second point says that this estimate of B1 from the change equation has exactly the same interpretation as the B1s in A and B. This is a point of great confusion to people. They think that if they estimate a change equation, somehow, everything's different. The interpretation you got to think about as a change, and the fundamental interpretation of B1 from this equation is different from these B1s, but it's exactly the same. It's the same parameter.
You mentioned in your paper that change models have lower reliability, or is this a residual change model?
We'll get to that.
Okay.
We'll get to that. Any question about this? There should be. You see what I'm trying to say? Yeah.
Well, can you just give an example of saying how you would interpret it and how it does not change in just your language?
$1,000 increase in income is associated with a minus 5% drop in child behavior problems. That interpretation, $1,000 change, drop in behavior problems holds at time age 5, holds at age 3, and this change equation is producing exactly the same unit change in income as associated with X unit changes in behavior problems. What's different, if you're doing a cross-section, you're looking at families or kids with different income levels, right? The identification of this income effect comes from looking across families and kids. You're pretending, or you're hoping that you're holding constant everything else that's relevant about those families and kids, so that you can just look at the income differences between those families and kids and figure out what the behavior problem effect is. Here, you're using variability within a family over time for the kid, right? So you're still changing income if income changes at all between ages 5 and 3. But it's that change that's producing the identification of this effect, and not changes across families. So it has the same interpretation, but its source of where you come up with the estimate differs fundamentally. And the fact that it's within the family over time leads to this differencing out of the persistent family effects, because they're the same within a family over time.
So 1 and 2 are between subject models, and 3 is a within subject model.
Pretty much, right, yes, right.
So you said that can get rid of the ZP, sorry.
Right. The persistent characteristics of families and kids that determine behavior problems. If there are time-varying characteristics other than income that are important, then you better measure them and include them. Otherwise, there still might be some lingering omitted variable lines.
So can you give an example of how you do that? How would you get rid of that kind of bias too?
Well, suppose that behavior problems were a function not only of family income, but parent mental health, right? And parent mental health is time varying. You could imagine that behavior problems are reacting pretty quickly to variations in parent mental health. So you want to control for changes in parent mental health in order to clean up the income effect you want to estimate. So you need parent mental health in all of these equations, and it becomes a change in parent mental health in the change equation.
So controls for time varying ones would themselves have to be change scores?
That's what the algebra dictates, right? If this is, if parent mental health is a concurrent predictor of behavior problems, then change in parent mental health has to be a predictor of changes in behavior problems. It just follows from subtracting one from the other. So this is the same model as this, essentially. Same parameter. And it all depends on whether conceptually an instantaneous change model makes sense for the kind of outcome that you're interested in. Yeah.
How do you determine, this may be a silly question, but how do you determine the difference, or whether it's time invariant or not? It seems somewhat of an arbitrary call. Like I could hear the argument that, parental mental state is fairly stable.
Well, if it is, then, and you try to measure it, if there's going to be at multiple points in time.
There's no change.
Yeah, exactly.
Okay.
Exactly.
Okay.
So as long as there's a chance that it's time varying in an important way, then you should probably measure it and see if that's right. Or turn to literature to try to see how stable it is over time.
So there's, okay.
But that's the best way. It's quite variable, as it turns out. Yeah.
So if the B1 and the third equation is interpreted the same,
Right,
B1 and the A and B,
right.
can the same be said of B2?
Yes. Right, that, you'd get exactly the same interpretation if you had parent mental health, either at age 5, age 3, or change as a predictor of behavior problems. Right.
Can you use this to determine whether the bias is time invariant or not? So, say you did all of these and you get dramatically different B1s with no controls that are change scores.
You
that
have
would imply,
different B1s here.
yeah, say you got different B1s, and that would imply that there was bias that was time invariant, right?
Well, that's a more complicated, I mean, it could be for theoretical reasons that you'd expect income to become increasingly important for behavior problems over time. I mean, you always have to go back to kind of conceptual model.
Well, I mean before that.
But if that's true, then you'd expect these coefficients to be different, this to be bigger than this, and this simple algebra is not adequate. You need, and the childcare paper presents this as a case where you kind of do a decomposition and you can figure out how much of it's change in coefficients, how much of it's change in the X variable itself.
Well, I guess more simply, if you see a difference between your between subject and within subject model, how should you interpret that? As bias?
That you've reduced bias from differencing out this. That's what usually happens. People would take, it's often the case that these numbers are bigger than this number. But these numbers are probably big in part because you haven't measured all the potential omitted variables. This B1 is not influenced by persistent omitted variables. Therefore, it's probably a better causal estimate of what the effective income on behavior problems is. That's usually the logic.
Yeah, so the better you do at actually specifying your model, the smaller the effect you find in some ways.
Exactly.
Does that interfere with getting published?
Well, which journal?
Yeah, sure.
No, but the way you should think about empirical research is to approach estimation from several different methods. Complete as possible controls ought to produce a pretty good estimate. A change model, for somewhat different reasons, ought to produce a pretty good estimate. There are still other kind of methods, propensity score methods, which are another way of controlling for these variables. You really want converging evidence on what B1 looks like. But if it's quite divergent, then you've got to ask, it might lead you to include a whole bunch more independent variables here to try to see if you can get closer to what you get down here. Yeah.
So should we always be somewhat suspicious of between subject models, no matter how many controls they throw in?
Yes. And that will ruin your life. No, seriously, you'll never be happy with anybody's empirical research. Never be completely happy. But what it should lead you to do is not to be content with just one estimate. You really want to try different strategies. You were hinting that you might have more error in a change in income measure than in a level of income measure. If that's the case, then measurement error biases this thing down usually, right? So maybe that's what's going on with the smaller B1 here than up here. So you have to worry about that kind of thing. So it's never that a change model produces the correct answer. Each model produces an answer that you have to think about in light of the possible biases associated with that estimate. But if in an empirical article you can come up with several different plausible ways of producing an unbiased estimate, and they end up pretty close to agreement, then you're going to be pretty content. And you know, we're talking about quantitative. It's the same thing with qualitative research. You do qualitative discovery. You really want to approach it in a way that if you think you've got the answer, you want to constantly challenge yourself whether that answer is right, and continue to push your data, your qualitative data, in new ways to try to see if indeed that's right. It's exactly the same thing. You really want something that's going to hold up. If someone comes along and does it with a different data set or a little bit different way, they ought to be producing pretty much the same estimate. So. Okay, so that's the instantaneous change model. As I said, accumulation of inputs is probably a more reasonable model for most of the child-based learning and social-emotional development kinds of analyses that one would want to do in an education school or a cognitive psychology program. So let's think about a change version of accumulation of inputs. You know, again, can we get a change model that differences out the biasing effects of ZP? That's really the chief advantage of thinking about change models. Well, suppose we've got change models for accumulation of inputs. Age 5, there's a version of this. Age 5 achievement. Let's do it this way. Achievement at age 5. All right. Function of the accumulation of family income from birth to age 5 plus ZT plus ZP. Now, if we also have achievement measured at age 3, let's say, this is our equation A. Equation B, achievement at age 3, is a function of income from birth until age 3 now. Right? We're accumulating the inputs up to the point that we're measuring achievement. Here we're measuring achievement at age 5, so we take income birth to 5. Here it's income birth to 3. And then we've got these other time varying and persistent determinants. So now our change equation becomes change in achievement, age 5 to age 3, is some function. So what are we going to have here? What if we have 0 to 5 and subtract 0 to 3? What are we left with?
Summation t equals 4 to 5.
Just 4 and 5, right? So it's B1 times t equals 4 to 5. This should be income. Income plus, now we've got change in ZT plus 0. Right, so you see what we're doing? It's 0 to 5 and 0 to 3. Right? And if we're taking income 0 to 5 and subtracting income 0 to 3, all we're left with is income between ages 4 and 5. So in effect, by subtracting age 3 achievement from age 5 achievement, age 3 achievement is capturing all the influences up to age 3. So the only thing that's going to influence change between age 3 and age 5 is income between ages 3 and 5, plus whatever these ZTs are at age 3 and 5. So again, B1 has the same interpretation in A, B, and C. It's just that if we can measure and estimate a change equation, then we're going to be estimating B1 in a way that's not going to be affected by persistent unmeasured influences. They're just getting subtracted out. Yeah.
They're still constant and.
Yeah, right, if it were, if it's exactly the same constant, then there wouldn't be a constant there. But yeah, you don't want to allow for a constant.
Okay.
I'm trying to concentrate on the important stuff. Yeah, you don't want to allow for a constant. So, can't tell if people are lost or just
It's really hot in this room.
going with the flow. Oh. So, what happened to the fan? Oh, turn the fan back.
Also, I think you can open that door here.
Yeah, Greg, for equations B, A and B, we can say like, for example, with, change the specific amount, change in income, because it's just affiliated, with the B1 coefficient has this certain effect on achievement. But how do we interpret that for C, for example, because if there's a difference?
It's exactly the same thing.
Same thing?
Yeah.
Okay,
It's trust algebra, right?
okay,
If this is true and this is true, then this has to be true, and that B1 has to be the same as those,
right,
right? So here again, it's a little bit different from instantaneous change. You're estimating the effect of additional $1,000 of income, right? Annual income on achievement. It's not a change in income as it was in the instantaneous change, right? So it's average level of income after age 3, before age 5. And it's variation in that's giving you the coefficient B1 as its affecting change. So it's not as, with the instantaneous change, we could say in one case you're going across families, in other cases you're going within families. Here you're still going across families that have different age 4 and 5 income. But the conceptual model leads you to interpret B1 in the same way, an effect of additional $1,000 on achievement change that's not biased by the time persistent characteristics. So it really is a matter of having the right model. Is accumulation of inputs appropriate? Is this a reasonable way of expressing accumulation of inputs? Does that same basic relationship reasonably hold at an earlier time point? If that's true, then you get this result. That's a matter of algebra.
I guess the reason I was confused is because we were talking about how B1 would change, would be smaller, and so I was trying to figure out which B1.
Right, but so,
which would be one I would use to talk about my results.
Yeah, so it's a difference between a parameter and a coefficient estimate of a parameter. B1 in our discussion is the parameter. It's the causal effect of accumulated income on achievement. When we try to estimate that parameter with this kind of model or this kind of model, we're going to get an estimate. When we try to estimate that same parameter with this kind of model, we're going to get another estimate. They're not necessarily going to be the same. And now we're speculating that this is probably going to be smaller and better because there's no influence from time invariant characteristics, right? And here there's no measurement problem because, you know, if you've got this survey measuring income every year, income between ages 4 and 5 is just as reliable as income 0 to 3, income 0 to 5, right? So you shouldn't worry about downward bias or measurement error because you're likely to have it measured just as well here as in A and B. Okay, so now we're ready to do the childcare equation, which is really just accumulation of inputs model. Let me put it over here. So in the NICHD article, we have cognitive ability of 54 months is some function of early care quality. Let's just call that care sub E. So early age 0 to 24 months, I think. Yeah. And late equals 24 to 54 months. So we're averaging childcare quality 0 to 24 months whenever it's available. There's some parameter associated with that. We also have a corresponding care sub late. And then there are a bunch of other things, but let me put in center-based, whether it was in a center-based care, early, center-based care, late. Turns out those results are somewhat interesting also. So this is average childcare quality 0 to 24 months, average childcare quality 24 to 54, average fraction of years in a center, 0 to 24 months, average fraction of years in the center, 24 to 54 months. And then we have our ZT and ZP, other variables. If it's the case that cognitive development is 24 months as opposed to 54 months, has the same general structure. Here cognitive ability at 24 months is going to only be a function of early care because the late care hasn't yet happened. Plus the early center-based care variable plus the Z variables. Alright, this is A, this is B. Now a change model is going to be a change in a cognitive test score. Put the constant in. If we subtract B from A, early care drops out. Right, that's constant across the two equations. So we're just getting the care late plus the center early, I'm sorry, so, I'm sorry. I'm not changing it. It's the same. B1, B2, B3, B4. B1 center early. There's no center late, but we still have B3 and B4. So if we subtract the two, we've got A plus just childcare quality late, and then just center late, because the center early drops out. We still have the B3 change in time varying. Other variables, but we don't have the persistence, right? That gets differenced out. So that's essentially what the model is. It's a simple accumulation of inputs model. There's no way that you can estimate an effective early care with a change model, right? Because you can't get a cognitive score at age 0 with any reliability. So what the change model does is presumably provide a better estimate, less biased estimate of childcare quality, but only in the later period. That's all you can get, and of center-based care in the later period. So the big question is, what do those two estimates look like? This is the kind of thing that comes out of most models in the childcare literature. What happens if you do a change model? How different is it? And we have a Woodcock-Johnson cognitive test score at 54 and 24 months. Standard deviation of 15. That helps with the interpretation of the coefficients. So there are various estimates. There's a set of cross-sectional estimates. And then there are change model estimates. Cross-sectional estimates, no controls. Controls for mother's education. And then kitchen sink. And the change models, no controls, and then kitchen sink. Kitchen sink is not a technical academic term. Right? And we can get estimates of care early from some of these models, care late, center early, and center late, and then we get an R square from these models. Okay, so let's do cross-sectional estimates with age 54 cognitive ability. So we essentially are estimating A, model A. So we just have 54-month cognitive ability, regress it on early and late childcare quality. The study went all out to measure childcare quality well. Early and late fraction of time the child's in center-based childcare, and then some of these additional variables, mother's education, a whole bunch of stuff as the kitchen sink. So what do you get? No controls. You get 3.35. For early care. That's saying another unit of childcare quality. Childcare quality is measured on a rating scale that has a standard deviation of 0.5. So a 1 unit change is really a 2 standard deviation change in childcare quality being associated with maybe a fifth to a quarter standard deviation increase in cognitive ability. No controls. If you control for mother's education, that drops in half, 1.64. And if you control for everything in the world, it drops a little bit more. But essentially, mother's education is the main confounder here, as you'd expect. More highly educated mothers are more likely to put their children in higher quality childcare and promote children's cognitive ability in other ways. Therefore, it's a prime omitted variable. So if you include it, your estimate of the simple association drops a lot when you adjust for mother's education. If you put in a whole bunch of other variables, it drops a little bit more. Okay, so let's continue across. Late care is a coefficient of 2.72 in this equation. Center-based care early, 1.20, insignificant. Late center-based care, 7.15. And an R square of 0.18. Okay, so this first row is one regression, no other controls, just those 4 variables. And you get quality being significantly associated with higher cognitive ability, not a big effect size, but significant. Being in a center early doesn't seem to benefit a child's cognitive development. This is no other controls, so you can't really talk about this being a plausible causal estimate. But center-based care late does have a substantial association. If you control for mother's education, everything drops. The 2.72 drops to 1.57. The early center-based care stays insignificant, but the late center care stays significant at 5.28. We get a lot higher R-square, 0.36. If we kitchen sink it, we get a further drop. Early center-based care insignificant. Late center-based care 4.10. And now we've got a R-score that's up to 0.43. So it's good to, as you're doing your analysis, to kind of go through this kind of sequence sometimes. You get an idea of what the associations look like when you're just controlling for quality and center-based care. Once you start putting in important potential predictors that might be correlated with quality as well as the outcome, you get substantially lower coefficients as you might expect. These are biased upwards because you haven't controlled for those things. Right? And the kind of bottom line, still from the cross-section, we haven't done a change model, looks like a one unit increase in quality early is associated with a little more than a point on this Woodcock-Johnson test. One more unit of quality late, 24 to 54 months. Similar kind of 1 point increase. There's no evidence that early center-based care helps kids, but being in the center late, 24 to 54 months, seems to, from a cross-section, seems to be one of the more important variables here. So being in the center all the time, age 24 to 54 months, is associated with 4 points higher on this Woodcock-Johnson line. Everybody see that?
What's the scale for the Woodcock-Johnson?
Standard deviation 15. Okay, so it still, is fairly, it's about a quarter of standard deviation. So that's not a lot, but it's bigger than a 1 point increase. But, we still have these CP variables to worry about. We've tried to control for as many as we can when we do the kitchen sink set of predictors, but let's do the change model and see what happens. Well, we can't get an estimate of early care, right? We can only get an estimate of late child care quality as well as late center-based care. No controls, we start out at 1.17, and then with controls, we're dropping to 0.59, insignificant. But with the same change model, the center-based care coefficient holds up a lot better. It drops down a little bit from 4.10, but not that much more. So we're still getting, even with a change model and with full controls, we're getting a 1 point change in center-based care, which means being in center-based care all the time as opposed to none of the time between age 24 and 54 months. It's associated with about a fifth, a little more than a fifth of the standard deviation increase in cognitive ability. Not huge, but quite significant. In contrast, there's really no evidence that childcare quality, as opposed to just being in the center, matters for kids' cognitive development. Not what the people running the NICHD childcare study want to see. These change equations, by the way, have much lower R squares. 0.02, 0.13. So, which one are you gonna believe? You think back to the pearls of wisdom that I have dispensed over the quarter. Bias is everything. Explain variance, nothing. And measurement, not so much.
But what happens for your not memory and quality adequate? So then isn't there a measurement in your X variables?
Well, this is like the income case, where you're measuring, you're not measuring change in quality, you're measuring quality between 24 months and 54 months. You're averaging it over that period, right? So, there's no reason why the measure of childcare quality should be any less reliable in the change equation than the level equation. It's not like instantaneous change, where it was change in income predicting change in behavior, and change in income is probably less reliable than level of income. Here, that's not the case, because in the change equation, you're still measuring average level of childcare quality during the late period over here. So that shouldn't be a problem. Now, Deborah does note that the people who were in charge of measuring childcare quality 54 months didn't do a very good job. But it's still averaging in the 36-month childcare measure, which, and 24-month, which were presumably measured better.
What did they do wrong?
Deborah's face turns a little red with anger when she recalls this. It just wasn't handled very well. You know, it's a very complicated coding process. This study was, the signature measures of this study are the childcare quality measures. They go in to childcare settings and they observe several cycles of time. It's 2 minutes on, 4 minutes off, 2 minutes on. And then they systematically, is it, I don't know if they videotape or is it videotape? I think it probably is videotaped, yeah. So they videotape potential interactions between the caregiver and the child, and then someone mounts a big operation where people code up the videotapes. That's where it comes from.
Well, I mean, I'm just asking what mistakes I made so that we don't make them someday.
Always know what's going on when you're coding from videotapes. You know, you've got to train people to be consistent, one from another, to be observing the same thing. And a lot of these dimensions of quality that get aggregated up into this overall quality index are pretty subtle. So two people looking at the same tape might judge.
So iterated reliability.
Yeah, so you've got to train for that, you've got to test for that, you have to retrain for that if you don't have consistency. And a lot of care was taken for all but the 54-month, and they thought it was all set up for 54 months, but the person doing it didn't seem to do a very good job.
So do these estimates change a lot if instead of this change model, you just control prior cognitive achievement at 24 months? The like quality.
But that's, oh, you mean instead of putting it as a change variable on the
Yeah.
left-hand side? Okay. Yeah, that's my next topic.
Okay.
No. So this version, where you've got change on the left-hand side, corresponds directly to the conceptual model of accumulation of inputs. Right? We had this accumulation of inputs model. This version, we subtracted the two and we got that. The conceptual model dictates that you should have change on the left-hand side. what people often do as an alternative to C is a so-called residualized change model, which looks very similar. It's got cognitive ability at 54 months, but instead of subtracting out cognitive ability at 24 months, it sticks cognitive ability at 24 months on the right-hand side. So we've got cognitive ability at 54 months as some function of care late, center late, plus D3 change in ZT plus, let's say C1 cognitive ability 24 months. So instead of having it subtracted out as a change variable on the left-hand side, people stick with cognitive ability at 54 months as a dependent variable, that have cognitive ability at 24 months as an additional independent variable. So there's a long history. Somebody famous wrote an article back in 1967, Lee Kronbach, saying you should never have change on the left-hand side of the model. And it turns out that argument was very influential but didn't make sense ultimately. And the Allison article that's in the reading list walks through the logic of why it doesn't make sense. We don't have time to go through that logic, but you know, for my money, if you start out with a conceptual model and it dictates a certain form for regression to be estimated, that's the form you should be estimating. Because if you estimate something different, who knows what the interpretation of these coefficients are, right? It's not tied to any conceptual model anymore. If you constrain you can go through exercises where you constrain the coefficient and state it to be equal to a constant, some value. You can do that. You can say, estimate this equation, but force C1 to equal 1. All right? Find the best fit, but force this parameter estimate to be 1. If you do that, then this is, let's say D. If you do that, then D is identical to C. Right? If this equals 1, then you can just subtract it from both sides of the equation and you get exactly this. So if you were to estimate this, D, constrain the coefficient on cognitive ability to be exactly 1, then you'd end up with exactly the same coefficients, exactly the same standard errors as C.
But D has a constant. C doesn't have the constant, A.
Well, I put one in. So this is just in response to, should you have a constant? If these are actually identical, then you shouldn't have a constant here. But I'm just allowing for the fact that there's a constant. But the point is, residualized change really is very close to a simple change model. But the fact that when you estimate a residualized change model, you allow C1 to be estimated as a parameter. You don't constrain it to any value. So that destroys the correspondence with the conceptual model. No longer do you have simple change. And who knows what you have? You know, what's the interpretation on BL and B2 anymore? Because it's different from what the conceptual model said you should be estimating. So why should you do it? But everybody does it. So there is, so you can come up with a logic for doing it. You know, up here, if there's a version of this that's just the late care and the late center, and you want to control as completely as possible for everything that you should control for and getting unbiased estimates of late care quality and late center-based care, you could do worse than sticking in age 24 months cognitive ability as a control variable, because that's picking up a lot of individual difference. So one way of thinking about D is that it's kind of estimating A with a really good control cognitive ability at 24 months. But that's the only justification I could see. If you want to do change, estimate change. You get a lower R square, but who cares? Right? You get interpretable coefficients, and that's worth a lot. You know.
So how much difference is there between a model where you have your change score as your DV, or one where you have the second score and control for the first score?
What do you mean? What's the difference? You have a much higher R square if you've got the lag dependent variable on the right hand side.
Well, ignoring, I mean, because you say R squared doesn't matter.
Oh, you'll get some differences. Sometimes not very big.
But they tend to look similar.
Usually not very big, right? The Chakra article does both residualized change scores as well as simple change. So you know you can get an idea of it's a similar picture in this case. But you know my main point that I started out with is if you go right to an empirical model, a residualized change score model, a latent growth model, you're not thinking about the conceptual model that might or might not be consistent. Right? Now maybe there's some other conceptual model apart from instantaneous change or accumulation of inputs or lag change that is consistent with this model. I don't know what it is, but you know, you might be able to come up with something. But it seems to me that you should do the conceptual thinking first and then let the empirical estimation be guided by what you think the conceptual model is.
So, to go back to your earlier point, when you asked which set of values we should really care about.
Right.
You would wanna care about the change model because that's the one that's accounting for the most bias, even though the R squared is lower.
That's exactly right. I'd want to go with this. You know, I'd hope that this wouldn't be that different from this if I had an awful lot of control variables here. But if it is different, and if measurement error in the change model isn't likely to be a problem, and I don't think it is, because, as I said, your measure of quality of late care is this average over several waves of observation. So, you know, it ought to be pretty good. Then it seems to me that the 0.59 is what you want to go with.
And this tells you it doesn't really help kids' cognitive ability, but it also tells you it doesn't really hurt them either.
What's the last part?
It doesn't really hurt them either.
Right. That's a pretty low standard, right?
You know,
We need to improve
it's the built-in
childcare quality
law,
because
right?
it doesn't hurt kids. Yeah, I mean, no one wanted to hear this. But, you know, it looks like, and this is confirmed in other kinds of analyses, if you really want to help kids' cognitive ability, the margin that seems to be more potent isn't varying quality within a center, but it's trying to ensure that kids are able to get into childcare centers if they want.
as to opposed to staying with grandma or.
That's what that says, as opposed to any sort of, it's often, family-based care of some sort. So, you know, it's also the case that the variation that we're capitalizing on here is the normal range of childcare quality, which is pretty crappy by and large, right? So, this really doesn't say anything about what you would get if you had really high levels of quality, because that's just very rarely observed. There's a paper that Peg Birchnall did that was looking for nonlinear effects, and it seemed to show that you weren't getting much action at all through maybe the first 2/3 to 3/4 of the range. If there's any action, it was in the higher quality range, right? So that's an important qualification.
So pay a lot or don't sweat it.
Yeah, I mean,
That's depressing for you, isn't it?
there are other ways of promoting. You shouldn't count on decent quality childcare as being something that's going to be important for promoting cognitive development, right? There are a lot of other ways of doing that in the home rather than outside the home. But it just doesn't look like, you know, and there are all sorts of, should states be requiring quality standards for childcare? They have this elaborate Eckers rating scale, right? Should we go out and try to rate? This bears very substantially on it. Yeah.
So we really can just like chain children to the TV and call it a day.
Change children's.
Chain children to a TV and call it a day.
Oh, change.
That's exactly right. And on that happy note.
All right.
So
Don't
next
have
week's
kids.
Memorial Day.